Alright, this is part 3 of our lesson about extending the number system. In this video, we will focus on working with radical expressions and converting back and forth between radical expressions and expressions with fractional exponents. And we'll continue working with radicals as we rationalize the denominator, which is a fancy way of saying rewrite it so that we don't have a square root or any kind of root in the denominator. First of all, understand how fractional powers work. Let's see, if I have n to the p over r power, so I'm dealing with fractional power. I picked these letters for a reason, because in this fraction the numerator is always the power and the denominator is always the root. Okay, power over root. So for that reason we could rewrite this. Okay, alright, so I have r is the root, so that goes here, and p is the power. Now I can either take that power and put it on the inside of the radical like this, or r was the root, I could take that power and put it on the outside like that. Alright, whichever is more convenient based on the problem. But the key is power over root. Power over root. Focus on that. Okay, so we're supposed to rewrite the radical expression or a fractional exponent and then evaluate. Okay, well, if I rewrote this radical expression, then obviously in terms of power and root, 3 is the power and 5 is the root. Okay, so if I rewrite this, so I have 7,776. Remember that we do power over root. So that's going to be 3 over 5. Okay, that's going to be the 3/5 power. Now they said then evaluate. Okay, what was it? 7,776 to the 3/5 power. Okay, that is 216. Okay, number 22. This time we'll go the other way. So we've got power and we've got root. So that means it's the second root. Okay, now for all other roots we write the little number right here. That's where you put the index, except for the second root. Second root is always understood. We don't put the number. So that is the second root, and the 5th power, which I usually will put on the outside. Now, so the square root of 25 is something that you know in your head. Alright, square root of 25 is 5. So we have 5 to the 5th power. And 5 to the 5th power is 3,125. Okay, number 23. Let's rewrite this in the other form. Okay, so obviously 4 is the power and 3 is the root, and we do power over root. Okay, so that means I'll have 729 to the 4 over 3 power, all right? Power over root. Okay, so 729 to the 4 over 3 power, 6,561. Okay, all right, so they're giving us this one as fractional power, so let's go the other way. And remember, it is power over root whenever you see a fractional exponent. Power over root. So we'll have 81, but 4 is the root, and 3 is the power. So we could rewrite it that way. It's actually easier to evaluate as the the base and the power. So what was it? It's 3/4 power. Okay. So this is 81 to the 3. Wait, let me start over. I said this is 81 to the 3/4 power. Okay, so it's going to be 27. But I do want to show you how to type a root in your calculator, all right? Because a lot of you don't know how to do this already. If I want to do the 4th root of 81, for example, the way you can do the 4th root is you start by typing the 4. And then you see this button right here, above the caret has X root. So that means any root we want. So if we hit second caret, that 4 becomes the 4th root. And then I can just type the 81. So it's 4th root of 81. And you see the 4th root of 81 is 3. Alright, so what really was happening here was that it became 3 to the 3rd power, and then that's 27. Okay? You could have even typed in the entire thing and written open parentheses, and then put your 4, and then do the second caret. So we've got the 4th root of 81. Okay, and then raised all that to the 3rd power. I mean, you could type in the entire expression and get 27. Alright, I'm just trying to give you as much knowledge as I can, both about the number sense, but also how to use the technology. Okay, what's next? Now let's talk about rationalizing the denominator. When we talk about rationalizing the denominator, the square root of 7 is an irrational number. So rationalizing the denominator means making the denominator rational. Alright, so we have to get rid of the square root. Now, one thing that we learned a long time ago is that when you multiply a radical by itself, like say if I have radical 3 times radical 3, well, radical 3 times radical 3 is radical 9. However, radical 9 is 3. And we learned a pattern, because, say if I had radical 7 times radical 7, that would be, 7 times 7 is 49. But then the square root of 49 is 7. Alright, do you see the pattern? Radical 3 times radical 3 is 3. Radical 7 times radical 7 is 7. So can we not skip the middle step? Okay, like if I had radical 6 times radical 6, okay, can we skip the middle step and go straight to the answer? What's that going to be? It'll be 6. Now sure, if I want to go back and think about why, I could. Okay, there's no law against it. This would be the square root of 36, which of course is 6. Alright, but I don't want you to have to do the middle step. So I should be able to give you crazy numbers that are too big to deal with in your head anyway. So if I said the square root of 1,234 times the square root of 1,234, you should be able to tell me the answer. 1,234. Okay, so know that pattern. We can use that to rationalize the denominator. If I want to make that radical go away, we just saw that we could multiply it by itself. So that's what I'm going to do. Let me leave a little extra space. I could multiply the denominator by radical 7. If I did that, radical 7 times radical 7 is 7. Now I can't just multiply the denominator and poof. I have to balance it out by doing the same thing in the numerator. Alright, that way I'm really just multiplying by 1, because anything over itself is 1, and multiplying by 1 won't change the value of anything. So 5 times radical 7, we would just write 5 radical 7. So there we just rationalized the denominator. Now, simple problems like this, I think the calculator would have done for us. But I need you not to rely on that. So 5 over radical 7, 5 radical 7 over 7. But it's important that you know how to do it yourself. Okay, so similarly right here, I could rationalize the denominator by multiplying the numerator and the denominator by radical 3. Okay, radical 3 times radical 3 is 3. But meanwhile, this 2 didn't go anywhere. And in the numerator, I have 5 radical 3. So that's going to be, of course, 5 radical 3 over 6. Okay, it's important that you know how to do it by hand. Let's see if the calculator would have been able to do one like this. I don't know the limitations. So 5 over, and then 2 radical 3. Okay, so 2 radical 3. Okay, 5 radical 3 over 6. So the calculator would have done that one too, which is good to know. Okay, now when we have a cube root, it's going to be a little bit different. When you're dealing with cube root, alright, it is helpful to keep in mind what the first several perfect cubes are. So other than 1 to the third power, which of course is 1, then we have 2 to the third power, turns out to be 8. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125. 6 to the third power is 216. This will get us pretty far. So these numbers are helpful because we can use them to know what the cube roots are. So for example, if I said what is the cube root of 27, the cube root of 27 is 3, because that's where it came from. Okay, so what if I asked you what was the cube root of 125? What's that? Say it. Yeah, the cube root of 125 is 5. Okay, fine, that's how that works. So the thing is, if I wanted to make the radical go away, so say if I had radical 3 times radical, say if I had the cube root of 9, what would I have to do? What would I have to multiply by to make the radical go away? Well, first of all, don't think, oh, isn't that just 3? No, that is false. Okay, the square root of 9 is 3, not the cube root. Alright, so don't make that mistake. Alright, so what you have to do is look and try to see what I can multiply by to get one of these. 9 goes into 27 3 times. So what I could do is I could multiply this by the cube root of 3. Now, the cube root of 9 times the cube root of 3 would be the cube root of 27. And of course, the cube root of 27 is 3. Okay, so it's a little more tricky than what we were doing before. So let's see if we can do an actual problem here. So here I've got the cube root of 4. Alright, I feel like we should deal with it off to the side. If I've got the cube root of, you know what, I'm going to deal with it right here. If I've got the cube root of 4, alright, what do I need to multiply by to make one of these? Well, you see the 4 right there. You know what? This is simplest. Okay. 4 goes into 8 evenly. Alright? So, what I could make this into the cube root of 8 then. So what would I have to multiply by? I would have to multiply by the cube root of 2. Alright, because the cube root of 4 times the cube root of 2 would be the cube root of 8. And then that would give me, the cube root of 8 is 2. And I'd have no more radical anymore. So that's why I need to multiply by the cube root of 2. Okay, so, it's not an eraser. So that is why I am going to multiply by the cube root of 2. And again, I have to do it in the numerator and the denominator. Okay, so that is going to give me, maybe I'll do one more step. So that's going to give me 6 cube root 2 over cube root 8. And then that's going to be, the cube root of 8 is 2. So now I have 6 cube root 2 over 2. And I won't stop there either, because 6 and 2, alright, 2 divides evenly into 6. 2 goes into 6 3 times. So that's why the final answer is going to just be 3 cube root 2. Okay, and your calculator will not simplify cube roots for you. Okay, if I could type this into my calculator and do 6 over, and we learned that if I want the cube root, you type 3 first and do second caret, and what was it? I just already forgot. Cube root 4. Okay, but your calculator is just going to give you a decimal. Alright, and so you can't just write down the decimal. We want an exact answer like this. So you're going to have to be able to do it by hand. Okay, now the 5th root. Okay, let's make a little chart of perfect 5th power numbers. So, you know, of course, 1 to the 5th power is 1. 2 to the 5th power, I happen to know is 32, but you would have to use your calculator, I'm sure. 2 to the 5th power is 32. Alright, let's just do a couple more, because these numbers get really big fast. 3 to the 5th power is 243. Alright, let's see if this is enough to deal with. So I've got the 5th root of 2. Alright, the question is, what would I need to multiply by to get one of these. Okay, I'm betting on the 32, you know, since it came from a 2, so it's definitely divisible by 2. Okay, so let's shoot for 32. So, we have to multiply a fifth root by another fifth root. So, 2 times what will give me 32? Well, that turns out to be 16, right? You know, because 16 is half of 32. So, 2 times 16 would be 32. Okay, so that means the fifth root of 2 times the fifth root of 16 is the fifth root of 32. And the fifth root of 32 is 2. Okay, so that's why we need to multiply by the fifth root of 16. So that's what we shall do. Alright, so we will multiply by the fifth root of 16 in the numerator and the denominator. So that's going to give us, in the numerator, the fifth root of 16. And in the denominator, well, we've already seen that it's going to turn out to be 2, but I guess we'll show it again. In the denominator, we've got, for a moment there, we've got the fifth root of 32. Okay, so the final answer is fifth root of 16 over 2. Okay, because we made our chart real quick. And the fifth root of 32 is 2. So if I were you, as soon as you see what the power, what the root is, just start making the chart. All right, 1 to the power, 2 to the power, 3 to the power, 4 to the power. Just make a few of them so you have something to play with. All right. Anyway, that is the answer for number 28. Okay, that seemed a little bit more difficult than anything we've done before. So sorry about that. All right. Anyway, that's the last problem for this video. Let's go ahead and stop it there for sure. In the next video, we will be evaluating by hand these radical expressions. We'll be adding them, subtracting them, multiplying them. Yeah, multiplying them. So I will see you on the next video, my good people.